Welcome to the Bootloader. I'm Todd Kurt.
And I'm Paul Cutler, and this is episode 1. The show works like this. Todd and I each have brought 3 things to share with you. We'll spend a few minutes talking about each, but no more than 5. If you want to learn more, we have detailed show notes available at thebootloader.net, and give us a follow on Twitter at thebootloader. Todd, why don't you get us started?
Okay, we all know how 3D printers normally work. You got a 3D model on your computer, you run it through a slicer program that chops it up vertically like a deli slicer, and then it creates instructions to draw in plastic on each of those slices. Those instructions, G-code, are sent to the 3D printer as one file. So a 3D printer is more like a 2D printer that stacks a bunch of 2D printed layers on top of each other. In fact, there was a 3D printer that used printer paper, a CNC knife, and glue to make 3D prints like 10 years ago or so. The benefit of this approach is that any 3D object can be sliced up without knowing how the object is built. The downside is you can't have graceful curves that move in 3 dimensions. But a 3D printer can move in all 3 dimensions at once. The 3D printer nozzle could move up and down while moving around in a plane, creating 3D structures that are impossible with traditional slicing approaches. There have been various research projects showing this, but the most approachable I just came across is the Fullcontrol design library. Go to Fullcontrol.xyz to check it out. It's a web-based demonstration of an upcoming open-source Python library. The 3D model has a beautiful, almost cyberpunk aesthetic with purples and blues and 3D wireframes. The site currently has a collection of hand-picked generative 3D designs. You pick one, you modify its design parameters, you click generate, and you get G-code directly downloaded from your browser. No slicer needed. I started playing with this, and it's really fun. I can't wait to play with the library itself.
I've been looking at some of those overhang challenges they have and wondering if my printer could actually keep up with some of those models that they show.
Yeah, it's nuts. I don't even know how like normally there's all these extra G code settings for your printer. I've been feeding a couple through my printer and they seem to work. So I'm really curious to see what the library looks like.
I'm going to have to give that a try, definitely. The first thing I wanted to share is about an open source project called Tio, T-I-O. Martin Lund is the developer, and I have a cool story about him too at the end. Tio just released version 2.0 on September 11th. I've been using CircuitPython for a year or two, and I didn't know about Tio until John Park featured it in late July on his show, the CircuitPython Parsec. Tio is a modern day replacement for the old Linux tool Screen. If you go to Tio's GitHub page, Martin shares the motivation for Tio: to make a simpler serial device tool for talking with serial TTY devices, with less focus on classic terminal modem features and more focus on the needs of embedded developers and hackers. It's that last sentence that's key. Up until July, like most users, I used Moo to see any serial output or errors with my CircuitPython devices. Even Adafruit's Advanced Serial Guide for Mac and Linux has you use Screen, the old Linux tool. I've been using a Unix-like operating system for too many years, and this is perfect for someone like me who is comfortable dropping down into a terminal. I can also run Tio in my IDE's terminal. It's got a lot of cool features, but it has one killer feature, which is auto reconnect. If I unplug my microcontroller and plug it back in, Tio automatically reconnects. I don't have to look up what serial device it was or type the command to connect. It's just there and running, just like my CircuitPython code is when I plug in a board. But that's not the only cool part. The Monday after the episode aired, Martin Lund joined the Adafruit Discord after he heard about the episode. He answered some questions and asked for feedback. It's cool to see open source collaboration like that in the open. And when 2.0 came out, Martin popped in Adafruit's Discord to let folks know the new release. A couple users shared a few bugs, especially on Windows, and he fixed them right away. He didn't have to do any of that, but what a way to go above and beyond. It's so cool to see open source collaboration happening in real time. If you're looking to level up your CircuitPython skills and move on from the Moo code editor, check out Tio. Todd, what do you have
Yeah.
for us next?
Oh, so just real quick, I super love Tio. The reconnect is great. I had been using Screen a lot. I'm a big terminal guy, and so Tio was right up my alley. Because of how CircuitPython sort of functions whenever you're doing updates, the whole reconnect thing kind of happens a lot, at least with the way I use things. So yeah, big thumbs up. So speaking of serial stuff with Python, the thing I'm going to talk about next is called Belay, Belay. Belay is a desktop Python library that remotely controls your CircuitPython or MicroPython device. Like if you are first coming to MicroPython or CircuitPython and you're an expert Python person, you might be in for a rude awakening that the restrictions and limitations that these little embedded systems have. You're used to like having gigabytes of memory, and you don't really have that. Um, and so if you don't need a standalone device, if you don't need the CircuitPython, MicroPython device running by itself on a battery, not connected to a computer, and really what you want is more of a smart peripheral that you can poke at from your computer, then what Belay does is it lets you kind of treat the sort of virtual serial port going from your computer to your CircuitPython device as this little tunnel that you can send Python code to. And so you just write in normal desktop Python, and you just use a special decorator to say, hey, basically send this code to the device. And so you're going along in your normal big Python program, have a little function, and it goes boop out to the CircuitPython device or MicroPython device, comes back with the result, and you can control pins, you can read inputs, you can do neopixels. Basically, you can just do anything you can do in CircuitPython, but you can have it written in your desktop Python. And that's really cool. If this sounds a little bit like Fermata, if you're an Arduino person, Fermata is this custom protocol and sketch that runs on an Arduino, kind of takes over the Arduino and turns it into a remote sort of GPIO device for your computer. And so Belay is a little bit like that, but because Python is Python, it's much more because you can just run arbitrary code, and that's much more interesting than just the sort of fixed protocol that Fermata supports. Belay is available on PyPy and on GitHub.
The developer
Links in the show
behind
notes.
Belay has been working on this nonstop. It just came out a month or two ago, and it's already
Oh,
on
really?
0.8. He
Nice.
first had MicroPython support, and then later added CircuitPython support, and he just keeps going at it. It's great watching that come along.
Totes.
I'm big into music, and this next one is a little fun for me. This is from the department of Rockstars Can Be Developers Too. Rivers Cuomo, the lead singer of the band Weezer, whom you may know from such hits as Buddy Holly, Beverly Hills, and Pork and Beans, was recently spotted on GitHub. It turns out he's an open source developer when not writing songs. He submitted a PR to another open source project, and he also has his own project on GitHub. He's written a Python app and released it under the GPL. Here's the description from his GitHub repository. A Python script to update a Spotify playlist every day with all the songs from any significant new albums. It shouldn't include single-only releases. Anything older than a month should be deleted. Interesting. And Mr. Cuomo goes on to share even more detail about it in the About section. This project is for me to experiment with open source collaboration, so please feel free to chime in and participate. I've been learning programming since 2015, but I've been mostly working on my own, so my GitHub collaboration skills are weak. I'd like to learn more about collaboration so I can accomplish more as a programmer through teamwork. He goes on to say, this project will be a first low-risk foray into the field of open source collaboration. If things go well here, maybe I can start to open up some of my other repositories. I could sure use some help. And I love the thought that some of my programs could be useful to others. My first goal here is to understand how different developers can work on a codebase together. So that's pretty cool. Now, I don't have a Spotify account to test it out, but you'll need a Spotify client ID and secret, and then you can customize the program to even exclude certain genres of music that you might not like. But if you do have a Spotify account and know a little Python, check it out and maybe even submit a pull request.
That's great. I love it when we hear of famous people that are secretly nerds.
Exactly. I don't mean to go all TMZ on the show, but once I saw that, it saw my two worlds colliding. I had to put that in the show. What do you have for us next?
All right. So another CircuitPython thing. Did you know that CircuitPython has camera support? Like, this is something that's pretty new. It seems amazing that it could even function, that like we could have like little microcontrollers with cameras. I mean, I know that's kind of like what cell phones are, but the class of processors that are in our little dev boards are like way below what's in a cell phone. So this hacker named Ashish, he used a Raspberry Pi Pico running CircuitPython on these little cheap camera boards and some clever machine learning stuff to do machine learning recognition of handwritten digits with the camera. So the camera's looking at a piece of paper, you write a digit down, and it says, "Oh, you wrote a 2." And this is just like two things that I didn't think would ever come to CircuitPython, like machine learning and vision. Like, here's one example that's both. And the way it works is, so on the PC, he has the actual training of the model, and that of course takes a lot of memory and a lot of memory and a lot of time. He used there's a standardized data set for handwritten digits, and he ran that through a classification system called support vector machines, which is a sort of simpler kind of machine learning that was all the rage like a decade or so ago. It basically tries to find hyperplanes that cut through the data to sort of separate out the data. So if you've got a multidimensional set of data, like an image is basically a multidimensional set of data. Like images for multiple handwritten digits is a big multidimensional set of data. You can use sort of the support vector machine math to kind of cut through the data to create these little nodules that are, oh, this is what a 4 looks like, this is what a 7 looks like. And the nice thing about it is that once you've trained the model itself is pretty small enough that it can run on a microcontroller. And normally I've seen this on C-based things, never something as kind of easy to use as Python or CircuitPython. And so once he trained it, he then minimized the resulting Python file, and that's like maybe tens or 20 of K on the flash. And so now you can have vision system CircuitPython machine learning. And Ashish has a whole blog post on how to do this and a GitHub that has all the code. So you can just use his trained model off the bat if you want to try that. I got a camera board just a few days ago, and I'm going to try this out this weekend. So let's see if it works.
That'll be a fun project, and we'll make sure to link to all of his work in the show notes too.
All right. So what's the last one?
We're going to come back to 3D printing. So what kind of 3D printer do you have?
I have a couple, but the one I'm used the most is a Prusa Mark 2.5.
Okay. So I'm going to talk about the Bambu Labs, which started a Kickstarter earlier this summer. Now, there's a rule in the 3D printer community to never buy a printer on Kickstarter for a number of different reasons I'm not going to go into here. Bambu knew that because before the Kickstarter went live, they sent out a ton of review units to YouTube hosts and other influencers. They all came back glowing about it. And a couple I even follow even said they'd be spending their own money to buy one. It was that good. The Kickstarter launched and they raised about 10 times what they were looking for. What's so cool about it is the X1 is generational. This printer sets the bar for the next generation of printers. It has built-in LiDAR for auto bed leveling, as well as some other bells and whistles. Like if you buy the Step Up, it's got the built-in webcam and can do time lapses, among other things. But the key selling feature here is how fast it is. It's up to 4 times faster than an Ender 3 or a Prusa.
Wow.
And the quality is excellent. I had a chance to help set up my best friend's X1 Carbon, and the hype is real. The out-of-box experience was wonderful. Everything was clearly marked, and we were up and printing in 15 minutes.
That's amazing.
Now, it really is. If you're looking to buy a 3D printer and looking at Creality Ender 3s, this is not the printer for you. But if you're looking at a Prusa, not the Mini, you might want to consider the X1. A fully assembled Prusa will run you about $1,100, and the Bambu has 2 models at $1,000 and $1,200, with the more expensive one having a slightly better build quality and some extras like the webcam that I mentioned. There is some risk with a new manufacturer. But they've made replacement parts for sale already and followed through on their promise to open source their slicer software. If this is what the next generation of 3D printers looks like, I'm really excited.
That's pretty cool. I mean, just the LiDAR kind of sold me. I'm like, okay, It's got something with lasers.
Yeah, and it's enclosed. It's slightly bigger than the Prusa and the Ender at 256 by 256. They've done a heck of a job. This is a first generation printer from them, so we have to give them a little time to see how the build quality holds up. But so far, so good.
Totally. I can't wait to check it out, like just to view some of the videos and stuff about it, because that sounds really neat. Thank you for listening to The Bootloader with your hosts, Paul Cutler and Todd Kurt. Follow us on Twitter at The Bootloader. For show notes, transcripts, and to support the show, visit thebootloader.net. See you next episode.